Alright, now before proceeding to UDT, I would like to explain you how to show the errors and how to program the error logic. So if you see in this logic currently, we have set some speed which is 72%, and I have used two sensors. This is the starting sensor, this is the ending sensor. So the sensor has a fixed distance between that, okay? And I know this distance because we can measure that. This is my 4-meter conveyor, and based on the position of these bars, I can calculate the distance if I'm not physically present there. Secondly, we know the speed by which this we are controlling the speed of this conveyor. So we know the distance, we know the speed, so we can calculate the time required for this workpiece to go from here to here. So I have implemented a logic in which if it takes more time than the expected time, which means the workpiece is stuck somewhere and the error LED will be on, which is the red indicator. If you want to see that, so let's have another pallet, and I will try to stop him, and you will see there will be an LED. So I will stop it here, and you see this red indicator is on. All right, if you want to try again, we can do that. So I will just take it away, and I have to reset the error first, and I start it again. So this time I stop here and I let it go. So the time for which I stopped is being noted. This is we are doing using the sensors. So when the sensors sense the object, it starts counting. And when this sensor senses the object in that particular time, it will reset the timer for the next boxes. So now this was, I think you understand the concept, but the more interesting thing is, for example, what if I increase the speed to 100%? Okay, now what will happen? Let's try. So I start, right? First I have to reset the error, which is red. So resetting the error, and we start. Now, because we increase the speed, the time should reduce. That is also implemented in the logic, which I will explain you how to do that. So now the speed is increased. I will again stop this box for 2 seconds, and I have this error. Okay, so how we can implement that? So let's see that in the logic. So I will go back to my old logic. This was the old program we saw the last time. So we need to make some changes here. So first of all, if I show the parameters, we need to add some few more parameters. Now what could be those parameters? The first parameter is the length between the sensor. Now we know that this you can measure in your practical application, but since it's a software, I know this conveyor is a 4-meter conveyor. You can see that is a 4-meter conveyor, and I counted these number of bars. These are 16 bars. Okay, so if I start watching here, let's count from here. So 4 meter and 16 bars. So if I take the calculator, 4 divided by 16 is 0.25 meter. So the distance between these two consecutive bars is 0.25 meter. So if I check the distance from here, so I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I will multiply this by 11. I have my distance 2.75 meter. Okay, so let's put this distance here. So I will call it I fixed length, fixed LENGT between sensors, and let it be real, and I will give the value 2.75. So we know the distance. And I check the manual of this conveyor. It says that the speed of this belt, this conveyor belt, at 10 volts, the maximum speed will be 0.8 meter per second. So you should know the speed of your belt as well. This is very important. So I will write maximum speed of belt. We can also take it as 0.8. This is the start value. This will be fixed. Okay, now what we have to do, we have to calculate the time. So I'll hide right here, time in, let's calculate in milliseconds. Okay, and let's have this millisecond in double integer. This is because the time ultimately which we have to give to the timer, the data type of the timer cannot be real. It should be double integer. That's why I took double integer. So we have these parameters here, and I was wondering if we need another parameter. Yes, we need I, because we are talking about, okay, let me write here, meter per second. We're talking about the belt speed in meter per second. So actual speed of belt, speed of, just speed belt is fine, in meter per second. Okay, so the speed which we were already getting here, that should be converted into meter per second. Okay, or maybe this one, or maybe the speed which we are getting here. So typically we will convert the speed in the parameter. So this speed was in percentage, so I can write in percentage. We have to convert this into meter per second, then we can find the time, because this is the variable speed, the speed which we are putting from the potentiometer. All right, so let's do that. So I will go to my, okay, now for this conversion of this time, conversion of the speed and calculating the time, I would like to make a new function. So I will take new block, make a function block and rename it as maybe error formula. Yeah, this is fine. Let's take it SCL, click OK. So I will take it out. Now we know that the speed is in percentage, which we know that we are giving from 0 to 10. The range of this is 0 to 10. So if I just put here comment speed range of 0 to 10 should be scaled to 0 to 0.8 meter per second. That's what we want. We want to scale the speed of 0 to 10. Okay, well, I will not write percentage because it should be in 100%, so I will write in voltage, because the voltage which we were giving is 0 to 10 volt. So voltage is a good name. So speed range of 0 to 10 volt, which was our input, should be scaled to 0 to 0.8 meter per second. Okay, so maybe I should use a different symbol here. This should not be, looks like a minus. Okay, now this is a very simple mathematics. So I will take here, this is my comment, I will take here speed in meter per second. That is equivalent to, now if you do some math by yourself, we will take the speed which is in voltage, multiply by 0.08. And now you will ask me how this number came, 0.08. Okay, first of all, consider the speed in voltage is 10 volt. Okay, this is many people have different way to calculate it, but just to make it very easy, you have maximum 10 volt. Okay, this maximum 10 volt should be converted to 0.8. So what I think in my mind, 10 multiplied by x is equivalent to 0.8. Okay, and now you can find out x. So x is equal to 0.8 divided by 10, which is equal to 0.08. Okay, that's how I do that. So maybe you have a different concept in your mind. So there are different ways by which people can do it, but I prefer to do this way. So now we have converted the speed, and this is now in meter per second. So let me just check it again. The data type, this is real. Data type in voltage is also real, multiplied by 0.08. Okay, but I wonder why I have this yellow line. Oh, double int, wait a second. I speed belt. Okay, so now it says it's in double int. We have to convert this into, because we are having the value in real, so I will convert that into double int. But I would prefer to do that in the next step. So what we do is, we take this, basically this you can also take in real, that doesn't matter, because in the end we just need the double int in time. So this real, I don't know, this comes automatically. Okay, Now there's no warnings or error. So we have converted the speed into meter per second. The second thing is we have distance and we have to calculate the time. So to calculate the time, we know that time is equal to distance upon speed. So I will put a comment, time equal to distance between the sensors divided by speed in meter per second. Okay, we calculate the speed, we know the distance between the sensor, I put it here, so just take the time. So time in millisecond. Okay, this is in double int now, so we'll do some consecutive steps. Time in double int, this is equivalent to distance, which was in real, so fixed distance comes here, divided by, now the speed maximum which we calculated, this is also in real. So these two parameters are in real, which is okay. So let me just make it bigger. So this is converted. Now this will give me the answer in seconds, but we want in milliseconds. So you will multiply with 1000. And now you will see a yellow line because this is in double int and this result is in real. So what you can do is you can maybe put instruction or you can just write real 2 double int, and then you need another bracket for opening it and bracket here to close it. Oops, and like this. So there's no error, no warnings. So what we have done, the time in millisecond is equal to distance upon speed, multiply by 1000 to get millisecond, and another bracket to convert it into double int. That's the whole logic. So we got the time in milliseconds here. All right. Now let's calculate, let's monitor this. So I will just download this, download from device, hardware software configuration. Just looking for the PLC. We got the PLC here. Load. Reinitialize. Loading again. Finish. Okay, let's go online and just we're going to check the speed in meter per second. So this is online, you can see that these values are loaded here, this is loaded here, voltage is 10, and if I start this again, now we are running it at the maximum voltage. So basically you can see that 10.0, and we have to calculate the time. Okay, one more thing. Since we made a new function, we have to call this function somewhere because otherwise it will not work. So never forget this error formula we can write in this network. So I will write error and I will just move this here. So let's download it now. We just want to calculate the ideal time. We want to see the ideal time for box to reach from one place to another. So this is downloaded. And now you can find the time here. This is 3.438 seconds. This is in milliseconds. So going back here, and let me try to make it small. And let's start this. Okay, you can see the time here. I think I should make it more small. Now I'm going to change the speed and you will see that the ideal time will change as per the speed. Oops, what's happening here? Let me see the formula again. Time in millisecond, fix length between the sensor, speed of belt in meter per second. That looks okay to me. Speed of belt. Oh, I took the wrong one. I should take this one here. I took the maximum speed. This is a wrong. I should take this one. Oh, small addressing problems. Never mind. This one here. Now let's download the logic. It's okay to make mistakes, then you know how to troubleshoot it, you know. So let's download it. Okay, now we have the time approximately 10 seconds at the speed, which is 36%. So if I increase it, you can see the time will reduce because now the speed is more. So at 100% speed, it expects the box to reach from one position to another in 3.4 seconds. And if you have a timer with your hand, you can calculate the time, which will be more or less equivalent to 3.438 milliseconds. This is the time when this sensor is on and this sensor is on between that. And if I reduce the speed, you will see proportionally time will increase. Now it's 5 seconds. This is what we want. So at this step, we have find out the time required for box to reach from one place to another. All right. In the next video, I will not make it too big. We will use this time to generate the error. So I'll see you in the next video.